Right now, a standard new car sold in the United States gets somewhere between 28 and 35 miles per gallon. The Toyota Prius, the car that spent 25 years convincing the entire world it was the king of fuel efficiency, tops out at around 57 miles per gallon in the city. So, when an official team from Guinness World Records flew into a test facility, ran a series of strict independent trials on a regular production sedan, and officially certified a fuel economy figure of 106 miles per gallon, the automotive world did not know how to react. That is not a misprint. That is not a tiny, fragile con sitting on a pedestal at a trade show under velvet ropes. That is a full-sized, real-world sedan rolling off a standard assembly line right now. To put 106 miles per gallon into actual American terms, imagine filling up a standard 15-gallon gas tank in downtown Los Angeles, driving all the way across the desert to Denver, turning around, and driving almost all the way back before you even see the low fuel light turn on. That single tank gives you roughly 1,590 miles of driving range. And the company behind this vehicle is not Toyota. It is not Honda. It is not Ford, General Motors, or Tesla. It is a Chinese company called Geely. What makes this breakthrough unnerving for traditional automakers is not just the mileage figure itself. It is what sits under the hood. The engine driving this car achieves a level of thermal efficiency that Formula One racing teams spend hundreds of millions of dollars trying to reach. And yet, this technology is already being prepared to land in driveways across North America and Europe, inside brands you know, trust, and drive every day. To understand why a 106 mile per gallon gas engine is sending shockwaves through the auto industry right now, you first have to look at what is happening to electric vehicles in everyday American life. For the last 5 years, car buyers were told a very simple story. Electric cars were supposed to replace gas cars entirely. The transition was presented as clean, easy, and inevitable. You buy an EV, plug it in at home, say goodbye to gas stations forever, and help save the planet. But as millions of drivers actually started living with electric cars day in and day out, the real-world trade-offs began to show up in ways the slick TV commercials never mentioned. Start with charging on a long drive. If you take a road trip in a traditional gas car, pulling into a gas station, filling your tank, and getting back on the highway takes less than 5 minutes. In an electric vehicle, even if you find a working high-speed supercharger, you are sitting in a parking lot for 20 to 40 minutes just to get your battery back to 80%. On a solo commute, that might feel like a minor inconvenience. On a family trip across state lines with restless kids in the back seat and a tight schedule, it completely changes the experience of travel. Then comes the winter problem. Electric car batteries run on chemical reactions, and cold weather slows those reactions down significantly. When temperatures drop below freezing across states like Michigan, Ohio, or New York, an EV can lose anywhere from 30 to 40% of its total advertised driving range. That 300-mile battery pack you paid $60,000 for suddenly becomes a 180-mile battery pack on a cold January morning. On top of range loss, there is the long-term cost question. Battery packs degrade over time, just like the battery in your smartphone. When an electric vehicle battery eventually dies outside of its warranty window, replacing it can easily cost between $10,000 and $20,000. That single repair bill can instantly wipe out years of fuel savings. And finally, there is the power grid itself. The US electrical grid was simply not built to support tens of millions of heavy power-drawing vehicles plugging in all at once every evening. Upgrading that infrastructure requires hundreds of billions of dollars and decades of construction. Electric cars are not bad technology, and they certainly have a bright future. But for millions of regular drivers who commute long distances, live in cold climates, or do not have a dedicated garage to charge in every night, going fully electric turned out to be a major compromise. This created a massive, unaddressed gap in the global market. What if someone could engineer a car that gives you extreme fuel economy, cutting your emissions and gas costs to almost nothing, without forcing you to deal with charging stops, cold weather range loss, or multi-thousand-dollar battery replacements? Automakers in Detroit and Tokyo thought that kind of jump was technically impossible. But while they were debating the timeline for full electric adoption, a company in China was quietly putting the finishing touches on an engine that proved them completely wrong. The company that just shattered the world record for engine efficiency did not start inside a multi-billion-dollar corporate research center in Tokyo, Stuttgart, or Detroit. It started in 1986 in a small farming village in Zhejiang Province, China. That was where a 23-year-old farmer's son named Li Shufu borrowed roughly $3,000 from his family to open a tiny workshop. He did not start by making cars, or even car parts. He started by manufacturing basic components for refrigerators. It was simple, low-margin, unglamorous work. But Li Shufu possessed an unusual operational focus and a complete refusal to back down from bigger rivals. By the mid-1990s, he transitioned his small manufacturing business into building motorcycles. Then, in 1997, he made a public announcement that caused executives across the global auto industry to laugh out loud. He announced that his company, Geely, was going to start manufacturing passenger cars. At the time, the idea sounded completely absurd. Li Shufu had no background in automotive engineering. He had no established supply chains, no massive assembly plants, no major institutional backing, and no experienced designers. When industry reporters asked him how he planned to build something as complex as a modern automobile, he famously dismissed their skepticism by saying that a car is really just four wheels, an engine, and two couches. The established industry ignored him, but Li Shufu kept building. In 2001, Geely achieved a historic breakthrough by becoming the very first private company in China to receive an official license to manufacture automobiles. Yet, local manufacturing was only the foundation of his ambition. Li Shufu realized early on that if he wanted to compete globally, he needed world-class Western engineering, safety standards, and manufacturing design. In 2007, he wrote an official letter to Ford Motor Company offering to buy Volvo, the legendary Swedish automaker that Ford owned at the time. Ford executives dismissed the letter completely. Undeterred, Li Shufu flew directly to the Detroit Auto Show in 2008 and pitched Ford's leadership again in person. Once more, he was politely brushed off. He returned in 2009 with more preparation, serious financing, and a relentless strategy. In 2010, the impossible happened. Ford agreed to sell Volvo to Geely for $1.8 billion in cash. The global automotive press was stunned. A young Chinese company with zero historical pedigree had just purchased one of Europe's most respected premium brands. But Li Shufu did not strip Volvo for parts. Instead, he gave Swedish engineers the financial backing and creative freedom they needed to turn the brand into a global success story, while quietly absorbing their safety practices, chassis design, and advanced manufacturing knowledge. In 2018, Li Shufu stunned the market again by purchasing nearly 10% of Daimler AG, the parent company of Mercedes-Benz, overnight, instantly becoming the single largest individual shareholder in one of the world's most iconic luxury car makers. Today, his company owns or controls Volvo, Polestar, Lotus, London Electric Vehicle Company, Lynk & Co., and major stakes in Smart and Aston Martin. The farmer's son who started with a $3,000 loan for refrigerator parts now held the keys to some of the most prestigious automotive engineering departments on Earth. And that exact combination of relentless ambition, massive capital, and cross-continental engineering power was directed at solving one specific mechanical challenge: building the most efficient internal combustion engine in human history. When Geely unveiled their new engine at the Beijing Auto Show, the crowd of international engineers in attendance stared at the specification sheet in absolute disbelief. The engine itself is called the BHE-15. It is a compact 1.5-liter four-cylinder engine. In terms of size, that is a small engine, the exact kind of displacement you would expect to find in an everyday compact car. On paper, there is nothing visually dramatic about it. But what this engine achieves with a single drop of fuel breaks a barrier that automotive engineers have been fighting against for over a century. The figure Geely put up on the big screen was 48.41% thermal efficiency. To understand why that number caused shockwaves across the automotive industry, you need to understand what thermal efficiency actually means in plain English. Every internal combustion engine ever built wastes the vast majority of the fuel you put into it. When gasoline ignites inside a cylinder, it creates an explosion of heat and pressure. But not all of that heat gets used to push the piston down and move the car forward. A massive amount of that energy escapes as raw heat out of the exhaust pipe. Another huge chunk gets absorbed by the engine block and radiated away through the radiator. More energy is lost to physical friction as metal gears and pistons rub against each other thousands of times a minute. Thermal efficiency is simply the percentage of total fuel energy that an engine successfully converts into actual kinetic motion. The average gas car driving down an American highway today operates at roughly 30 to 35% thermal efficiency. That means up to 70 cents out of every dollar you spend at the gas pump is completely wasted as useless heat before it ever reaches your tires. For decades, Japanese automakers led the world in thermal efficiency engineering. Toyota spent billions of dollars refining their world-famous hybrid powertrains, eventually reaching a peak thermal efficiency of 41% in their standard production engines. That 41% milestone was considered the absolute mountaintop of mass production vehicle engineering. Most experts believed that pushing past 45% in a car regular people could afford was physically impossible due to the laws of heat transfer and friction. Geely did not just cross that limit. They blew right past it, reaching 48.41%. Guinness World Records audited the engine, verified the testing under lab conditions, and officially certified it as the highest thermal efficiency ever recorded for a mass-produced automotive engine in human history. To understand just how extreme that 48.41% figure really is, look at Formula One racing. Formula One cars are the most expensive, most technologically advanced, and most obsessively engineered motor vehicles on the planet. Elite racing teams spend over $100 million a year tweaking custom hybrid power units to push their thermal efficiency to around 50%. Geely has mass-produced an engine for everyday drivers that sits within less than 2 percentage points of a multi-million-dollar Formula One race car. They did it by using ultra-high-pressure fuel injection that atomizes gasoline into micro droplets, a hyper-optimized combustion chamber design, advanced low-friction coatings on internal components, and zero-loss exhaust heat recirculation. They took the ultimate goal of combustion engineering, extracting nearly half of the total energy hidden inside gasoline, and made it scalable for mass production. But an engine sitting on a laboratory test stand is only a dynamic blueprint. The real test comes when you drop that engine into a heavy, real-world car, turn on the air conditioning, and put it on an open road. An ultra-efficient engine sitting on a factory test bench is an impressive engineering achievement, but lab numbers do not mean anything to an American driver sitting in highway traffic. What matters is what happens when you install that engine into a heavy, real-world passenger car, load it with passengers, turn on the air conditioning, and drive it down an actual road. Geely took the BHE15 engine, paired it with a 308 horsepower electric motor, and connected the entire system to an AI-driven energy management brain. They installed this powertrain into a full-size sedan called the Geely Galaxy L6 and took it to a closed-loop highway circuit in Hainan for official real-world efficiency testing. The results were certified by Guinness World Records for a second time. The car achieved an average fuel consumption rate of 2.62 liters per 100 kilometers. Converted directly into US measurements, that equals 106 miles per gallon. To grasp how radical 106 miles per gallon actually is, compare it directly to what traditional hybrid leaders have accomplished. In 2024, Toyota took their flagship Prius on a highly publicized, carefully planned drive from Los Angeles to New York City, specifically to showcase the absolute outer limits of their hybrid technology. Across that cross-country showcase, Toyota achieved an average of 92.9 miles per gallon, a number that automotive journalists rightly celebrated as a historic triumph for Japanese engineering. Geely's production sedan beat Toyota's best effort by more than 12%. Following the record verification, Geely executives openly stated to the press that their hybrid technology had officially surpassed the systems built by Japanese automakers, the very companies that invented and dominated the hybrid market for 30 years. Consider what a 106 mile per gallon hybrid means for everyday driving realities. If you own a standard car with a 15-gallon gas tank and an average fuel economy of 30 miles per gallon, you get roughly 450 miles out of a full tank before needing to stop. That same 15-gallon tank, operating at 106 miles per gallon, provides nearly 1,590 miles of uninterrupted driving range. That is the equivalent of driving from Los Angeles, California, all the way to Denver, Colorado, turning around, and driving back past Utah on a single fill-up at a standard gas station. For the average American commuter driving 30 miles a day, this means visiting a gas station maybe once every 6 to 8 weeks. It eliminates public charging stops entirely, removes winter range degradation, and completely sidesteps battery anxiety. You get all the carbon reduction and fuel-saving benefits of an electric vehicle without changing a single habit about how you refuel, travel, or live your life. It proved that the hybrid was not just a temporary compromise on the path to electric cars. Engineered correctly, it could become the most practical, high-performance solution on the road. Geely's 106 mile per gallon record is a massive milestone, but it would be a mistake to treat it as an isolated fluke. What makes this shift so dangerous for legacy automakers in Detroit, Tokyo, and Germany is that Geely is not acting alone. They are simply the leading edge of a massive industry-wide technological wave taking place across China's auto sector. While Western car companies spent the last 5 years laser-focused almost exclusively on pure electric vehicles, often scaling back their hybrid development programs, Chinese automakers executed an aggressive parallel strategy. They invested tens of billions of dollars into advanced electric cars, but they simultaneously poured immense engineering resources into hyper-efficient hybrid powertrains. The result is an intense domestic arms race, where multiple domestic brands are regularly breaking range and efficiency records. Take BYD, the Chinese automotive giant that recently surpassed Tesla in global electric vehicle production. In 2024, BYD released its fifth-generation hybrid system, achieving a certified 46.06% thermal efficiency. While slightly behind Geely's 48.41% world record, BYD's production hybrids are capable of traveling over 1,300 miles on a single tank of gas and a full battery charge combined. To put 1,300 miles into context for an American driver, that is the exact driving distance from Miami, Florida, all the way to Boston, Massachusetts, driven continuously without stopping once for gas or electricity. Other major Chinese automakers are hitting almost identical milestones. Chery, Changan, GAC, and Great Wall Motors have all rolled out production hybrids, offering thermal efficiencies well over 44% and total driving ranges exceeding 1,200 miles. These are not experimental concept vehicles stored in private laboratories. These are mass production cars sitting on showroom floors right now, selling to millions of consumers at highly competitive price points. Meanwhile, top hybrid engines from established industry leaders like Toyota and Honda sit around 40 to 41% efficiency. Legacy American automakers like Ford and General Motors rely heavily on hybrid systems, operating at efficiency levels below 38%. That gap between 38% and 48% thermal efficiency is not a minor competitive margin. In automotive engineering terms, it represents a generational leap. It is the technical equivalent of comparing an old dial-up internet connection to modern fiber optic cable. The underlying propulsion technology has shifted to an entirely new tier performance, and the traditional auto giants are suddenly finding themselves years behind on a technology that millions of global consumers want right now. It is easy for drivers in the United States to look at news out of Beijing or Shanghai and assume it is a distant foreign story that will never directly affect them. High tariffs, geopolitical tensions, and strict trade regulations make it very difficult for Chinese-branded cars like Geely or BYD to land directly on American dealership lots under their own names. But this engine technology is not going to stay locked behind international borders. It does not need to cross the ocean with a Chinese logo on the grille, because Geely has spent the last decade building a global corporate web designed specifically to bring its engineering straight into Western markets. Geely does not just manufacture cars in China. Geely owns Volvo outright. They own Polestar. They own Lotus. They hold a massive joint venture with Mercedes-Benz to design and manufacture smart vehicles. And through a massive global powertrain partnership called Horse Powertrain, co-owned alongside French automaker Renault, Geely is actively licensing its hyper-efficient engines to automakers across Europe, South America, and Asia. What this means for the American driver is straightforward. The 106 mile per gallon technology engineered in Hangzhou will enter Western driveways wearing badges that feel completely familiar. This engine tech is already integrated into Volvo's global engineering roadmap. It will show up inside upcoming hybrid SUVs, luxury sedans, and crossovers sold across North America and Western Europe over the coming years. You will sit behind the wheel of a sleek, comfortable European vehicle, turn the key, and experience the benefit of a 48% thermal efficiency engine without ever realizing the engineering underneath was developed by a private company in China. For Detroit and Tokyo, this is the ultimate strategic reckoning. The traditional auto industry operated under the firm belief that hybrids were just a temporary bridge technology, a minor stepping stone on the way to a pure electric future that they could take their time developing. Geely just proved that the bridge is far longer, vastly more advanced, and significantly more capable than anyone in the West ever predicted. The farmer's son who borrowed $3,000 to make refrigerator parts just re-engineered the internal combustion engine and proved that the future of driving was not decided in Detroit, and it was not decided in Tokyo. It was decided in Hangzhou, and every driver on Earth is about to feel the shift. If this video opened your eyes to where auto tech is actually heading, hit that like button, subscribe, and turn on notifications so you never miss a story. Now I want to ask you, if a luxury hybrid could give you 106 miles per gallon and 1,500 miles of range, would you still choose a pure electric car? Drop your answer in the comments below.